This lesson will be about arithmetic sequences and series. A sequence is called arithmetic. Sometimes we can say arithmetic progression if it has a constant difference. That means between any two consecutive terms of the sequence, the difference is constantly the same, and let's call it d. So formally the definition of a constant difference is an plus 1 minus an, where n can be any natural number. So this formula represents the difference between any consecutive terms. And here we have two examples of such a sequence. All odd numbers, 1, 3, 5, 7, general term of an odd number is 2n minus 1, because the expression 2n guarantees that we have even number, and then if we subtract 1, that becomes an odd number. So in this example, the common difference is just 2. Any two consecutive terms differ by 2. And another example. Here the common difference looks like is negative 5. We are dropping 5 every step. And the general term is given as 15 minus 5 times n. So if n is 1, we'll subtract just 1 5 from 15, leaving us with 10. If n is 2, we subtract 10, so our second term becomes 5, and so on. Common difference, negative 5. We can see any arithmetic sequence in a following form. If the first term is a1, then the next term is our previous term a1 plus the common difference d. So a2 is a1 plus 1d. And the following term will be whatever we had before plus another d. So it's a1 plus 2d. So we have the third term of arithmetic sequence is the first term plus two differences. Similarly, the fourth term is the first term plus three differences. So you see the relation between the index of the term and how many times we added the common difference is 1 less than the index. So if we want to develop the formula for the general term an, that will be the first term plus 1 less than n, that means n minus 1 times the common difference. Therefore, we can state that a general term an for any arithmetic sequence can be expressed as the first term plus n minus 1 of common differences. So let's practice. An arithmetic sequence an starts with ln3, so this ln3 is really just the first term of the sequence and has the common difference ln2. So this is our d and that's our a1. Write the first four terms of this sequence. Well, a1 we already know is just ln3. What's a2? a2 is ln3 plus ln2. This can be seen as, recall the properties of ln's. If we add ln's, that's the same as ln of a product, ln of 3 times 2. Okay, let's list the next term, a3. That would be the first term, ln3, plus 3 minus 1, that means 2 times ln2. And again, if you recall properties of logarithms, we can bring this 2 as an exponent inside the ln, and then we can convert this addition into multiplication. So overall, this expression is equivalent to ln of 3 times 2 squared. And similarly, we can come up with the a4 that is equal to ln of 3 times. Let's observe the pattern. This was 3, the exponent is 1 less. So it will be 2 to the 3, 1 less than 4. So we have the first four terms of this sequence. Those are the terms. And second question asks us to find the general term of the sequence and then find its tenth term. Well, if we observe the pattern of the first four terms, we can claim that an, the nth term, will be ln of 3 times 2 to d, and the exponent should be 1 less than n. So we write n minus 1. So that's a general term. And now the tenth term, a10, equals ln of 3 times 2 to the 10 minus 1 is just 9. In the next example, we want to find the general term of the arithmetic sequences. Well, in order to find out general term, we need to know the first term, and yes, we do. And we also need to know the common difference d. So, what's the common difference? Well, negative 9 minus negative 13 is like negative 9 plus 13, so it's 4. We're adding 4 all the time. The common difference is 4. As soon as we know that, we can figure out what the general term an is. Well, that's the first term, which is negative 13, plus the n minus 1 number of common differences times 4. Well, now we can simplify this a bit by multiplying by a bracket, collecting like terms. So we'll end up with 4n, and then it's negative 13 and negative 4, so it's minus 17. That will be the general term here. And let's see what we have in the second example. This sequence is not numerical. The terms of this sequence are expressions, but we can still observe that the common difference from the first term to the second term is like, let's take the x squared plus 1 and we subtract x squared minus 2. So it's 1 minus negative 2, so it's actually 3. The common difference is 3. Also, if we check the difference between this and this, it will be 3 as well, because x squared cancels and 4 minus 1 is 3. So yes, that's our common difference. Therefore, the anth term is the first term, which is expression x squared minus 2, and then we need to add n minus 1 of common differences, which means 3. So, if we simplify a bit, we have x squared plus 3 times n, 3n, and then it's negative 3 and negative 2, negative 5. So this whole expression is the general term that depends on n. The x squared is constantly the same, but the n influences the constant that is added to the x squared. And what do we have in the next example? Find the 20th term of an arithmetic sequence whose fourth term is 3 and 8th term is 13. Remember, to find a20, we need a1 and d. So first, let's focus on how to find out a1 and d, and then it will be easy to find out a20 from a formula for general term of arithmetic sequence. What do we know? We know a4 and we know a8. Well, let's write down the equations that comes from this information. a4 is a1, that we don't know, plus 4 minus 1, which is 3, times d. However, on the other hand, the question gives us the information that a4 is 3, so this expression is equal to 3. We have first equation that relates a1 and d. Well, since we have two unknowns, we need another equation in order to solve for these unknowns. The other equation will come from the second piece of information. a8 is 13. So what's a8? a8, according to the formula, is the first term plus 8 minus 1, 7 times the differences, equals, and the question says it equals 13. So that's second equation. Oh, now we have system of equations, so we can solve them for a1 and d. For example, if from the bottom equation we subtract the top equation, then we end up with a1 will cancel, and then 7d minus 3d is 4d, equals 13 minus 3 is 10. Therefore, d by itself is 10 quarters, or after simplifying 5 halves. Oh, that's good, we already have d. As soon as we have d, we can come up with a1 by plugging the value for d, for example, into the first equation. So, a1 plus 3 times d, which is 5 halves, equals 3. And we need to solve for a1. So, a1 equals 3 minus this whole number, which is 15 halves. Well, 15 halves is like 7.5. So 3 minus 7.5 is negative 4.5. Or as a fraction, negative 9 halves. Okay, so we have a1, we have d. Now we're ready to give the final answer. Therefore, a20 is a1, which is negative 9 halves, plus 20 minus 1 is 19, times the common difference, which is 5 halves. So if we multiply 19 times 5, that will give us 95. So under common denominator we'll have 95 here and minus 9 over there. Therefore, 95 minus 9 is 86 over 2. So the final answer is a20 equals, we can divide this to 43. Okay, let's review again what we've done in this question. We set up two equations using these two pieces of information about the sequence, and then we solve the system of equations for a1 and d. As soon as we have d and a1, plug it into the formula for a20 and we got the answer. Let's observe how to find partial sum Sn of the first n terms of an arithmetic sequence. Sn, from the definition, is the sum of the first term a1, the second term, which is a1 plus d, the third term, which is a1 plus 2d, and so on until we'll get the a-nth term, which is over here, a1 plus n minus 1 times d. Let's write this partial sum again, but starting from the last term, an, and then one below term will be an minus d because they differ by common difference d. And then the previous term, an minus 2d, and so on until we'll subtract all n minus 1 d's. So those two sums are the same. However, by writing in such a form, we take advantage of the fact that the sum in each column will be actually the same, because we are adding a1 plus an, but the d's will be gone. So the sum in that particular column is a1 plus an. But let's see the next column. That looks exactly the same because the 2d and negative 2d cancel, so we still get a1 plus an. Obviously, the first column results in the same a1 plus an. And so on until we'll get the last column, which again, after adding, the d terms will be gone, and we end up with a1 plus an. Why this is useful? Well, because then we have two sums on this side, and we can solve this equation for single sum Sn. If we count how many columns we have here, this is the first term, this is the nth term, so we really have nth column. So it will be n times of the same sum a1 plus an. And then we divide by this 2 to solve for just Sn. So the 2 goes to the denominator. So here we have a formula for the nth partial sum of any arithmetic sequence. Very important formula. Please highlight it and memorize it. So here's the formula from the previous slide. N times the sum of the first and the last term over 2. Or it could be written 1/2 of the product n times the sum of the outside terms. This formula is equivalent to the following formula that involves only first term and the common difference. How this was obtained? Just by replacing an by a1 plus n minus 1 times d. So we have a1 plus a1, that's why we have two a1s, and then it's n minus 1 times d is over there. So this formula comes directly from the previous formula and this general term an. So if you have your list of favorite formulas, you may want to include it. I usually remember just this one and the general term because you can always convert from these two to that one. Notice that if an in this formula is just an n, so for example, if we're talking about sum of consecutive numbers from 1 to n, that this formula really confirms the formula that we developed in the previous lecture. We have 1/2 n times n plus 1. This is our n plus 1, the first and the last term. Or we can just simply think the sum of consecutive numbers from 1 to n is the last number times the next number over 2. Find the sum of the first 100 terms for each arithmetic sequence. So here we have a sequence of odd numbers. We have a1, which is 1, and we have d, which is 2. They differ by 2. So as 100, according to our rule, is 1/2 of n, which is 100, and then we need to add the first and the last term. The first term is visible, is 1. The last term we actually should calculate. Maybe let's do it at the top. 100 is a1, which is 1, plus 99 times the common difference 2. So altogether, 100 is 199. Therefore, here we have 1 plus 199, the 100th term, and we need to simplify this. So after reducing with 2, we have 50 times 200. So altogether is 10 and 3 zeros. 10,000. Very large sum, but using the formula, it was easy to calculate. And the second example, this time we have the formula for the nth term, so it should be even easier, as 100 equals 1/2 times 100 times a1, but if n is 1, we have 3 plus 4, which is 7, plus 100, but if n is 100, we have 400 plus 3, we have 403 here. Okay, and simplify, that will be 50 times 410. Altogether, 20,500 overall sum. Now find the nth partial sum of the arithmetic sequence. And the nature of sequence is kind of unusual because the nth term is given by an expression. Okay, let's see what we have here. The n is given is 20, so we really need to find S20. Now according to the formula, this would be equal 1/2 times n, but n is 20. And then the first term, that means a1 when n is 1, is 1 minus x, plus a20. How much is a20? Well, the n is 20, so it's 20 minus x. Let's simplify this. The 2 and the 20 leaves us with 10, and the bracket is 21 minus 2x. We could multiply through the bracket, we'll get 210 minus 20x as a final answer for the 20's partial sum. In the following example, similarly as before, we need the nth partial sum, but the n is 12, so we really need S12, which is 1/2 times the number of terms, which is 12, and then it's a1, which is just 5, plus a12, which is 5 times 12. So altogether we have 6 here, and then this is 60 plus 5 is 65. So 6 times 65 turns out to be 390 as your final answer. I'm sure you often used term like average, for example, average of your marks. Our commonly known average is really a case of arithmetic mean. So arithmetic mean of two numbers a and b is defined to be an average of these two numbers. That means we are adding the numbers and dividing by 2 in this case. Notice that this has something to do with arithmetic sequence. If we line up numbers a, and then the mean a plus b over 2, and then b, that these three numbers actually form an arithmetic sequence. What is the common difference of this sequence? Well, it's not difficult to calculate. For example, if this is one difference and that's second difference, therefore the easiest way would be to take the difference b minus a and divide it by 2. That will be the common difference. So it's a difference between the larger number and the smaller number divided by 2. Well, we can double check if we use just the consecutive terms as prescribed in definition. That will be a plus b over 2 minus a, for example. If you put this under common denominator, then we have a plus b minus 2a, which is really the same as b minus a over 2. So yes, that confirms. Okay, so in this sequence, we inserted a number between a and b such that the sequence became arithmetic, and such number is called an arithmetic mean. It happens that we can actually insert between a and b more than one number, for example k numbers, which will be called arithmetic means if the new sequence created that way is really arithmetic sequence. So obviously those means needs to differ by the same number. Okay, how can we insert a few arithmetic means? For example, here we are asked to insert 4 arithmetic means between 5 and 8. Well, if I have 5 here, well, we could pretend that 5 is our first term in a future arithmetic sequence, and then we need to insert 1, 2, 3, 4 numbers such that they will create an arithmetic sequence together with the last one, which is really a6, because that's 1, 2, 3, 4, 5, 6, and this a6 is equal to 8. Okay, but we know that a6 is equal a1 plus 6 minus 1, which is 5, times common difference. So from this equation it's easy to find out the common difference because we know a1. a1 is 5. Therefore, to solve this for d, we have 5d equals 8 minus a1, but a1 is 5. And then we solve for d, it is really 3/5. So we have the common difference and we have the a1. Therefore, we can recover all 4 numbers in between. Therefore, a2 is 5 plus 3/5. Since 5 is 25/5 and 3/5 is 28/5. a3 is a2 plus 3/5, so it's 31/5. a4, 31 plus 3 is 34/5. And a5, 34 plus 3 is 37/5. We have all 4 arithmetic means inserted between 5 and 8. The following exercise is quite interesting. We need to find a formula to find the sum of the first n positive even numbers and then odd numbers. So the first n positive even numbers, let's list them. That will be 2 plus 4 plus a few more numbers until we reach 2n. That's the nth term of even numbers. And how can we calculate this? Well, we could do it in 2 ways. Either directly from the formula, because we're dealing with the Sn, nth partial sum of the arithmetic series of even numbers. And according to this formula, it is 1/2 times n times the first term, which is 2, plus the last term, which is 2n. Now, if we factor the 2 from the bracket and reduce with this 2, then we end up with n times n plus 1. That's 1 plus n, but it's nicer to write n plus 1. So here's the formula. However, I can show you another method Just to use the nature of the numbers and what we already know about the sum of consecutive numbers, this could be written as pull the 2 as a common factor out, and then we really have sum of n consecutive numbers. And we know very well this formula, that will be 2 times, and that formula went like last number times the next over 2. So as you see, yes, that's the same. It confirms the previous formula, n times n plus 1. Here it is. And now it would be nice for you to stop the video and try on your own. Develop a formula for the sum of the first n positive odd numbers, and then check with what I do in a second. So similarly as before, let's list our n odd numbers, starting with 1, then 3, then 5, and then the nth odd number, the formula for it will be 2n actually minus 1. Why minus, not plus? Well, we just need to check. The second number, if n is 2, we should end up with 3. So 2 times 2 will be 4. To get 3, we need to subtract 1 rather than add 1. So that's why it's 2n minus 1 as an nth term. Okay, so this could be treated as before as the nth partial sum of consecutive odd numbers. And according to the formula, it will be equal 1/2. The number of terms is n. And then the first term is 1. The last term is 2n minus 1. So as you see, the 1's will be reduced. And then the 2's can be reduced. So what's really left is n times n. Oh, that's beautiful. It's just n squared. Fantastic. Very nice formula. Our last exercise is an application problem. The seating section in the theater has 27 seats in the first row, 29 seats in the second row, and so on. So it's 27, 29. It looks like it's 2 seats more and more. So it's 31, and so on, increasing by 2 seats each row for a total of 10 rows. Okay, so we know how many terms we have. If this is A1, the last one will be A10s. Well, at that moment we don't know what it is. We can figure it out later. How many seats are in the 10th row? So that's a question of this number. What's A10? And then how many seats are there in the section? Oh, in the whole section. So the second question will really call for something that is called S10, the partial sum of the first 10 terms. Okay, but let's start with A10 first. A10, since this is arithmetic sequence, we follow the formula for the general term. It is the first term, which is 27, plus 10 minus 1, which is 9, times the common difference, but the common difference is 2. So that wasn't too difficult. We have 18 plus 27, which gives us 45. 45 seats in the 10th row. And to answer the second part of the question, we need to calculate S10. S10, according to the formula, is 1/2 of times the number of terms, which is 10, and then the first term, which is 27, plus the last term, which we just calculated to be 45. Okay, we can reduce the 2, and we have 5 times, this is 60, 72. 5 times 72 becomes 360. So there's 360 seats in the whole theater.